In this question, you asked to create an algebraic expression given the following, where you have this figure followed by this figure and finally this figure right over here. And you're asked to think about the following. How are you going to be creating an algebraic expression where we need to first recognize that yes, there is a pattern as you move from this to this and to this, and you can indeed predict the future in terms of how many of the objects are in a specific category. And so in order for you to accomplish this, first is you need to do the following, which is, yes, we have to recognize that building a table of values will enable us to take our figures that we have right over here to the next phase. And this table of values will reveal what? The pattern rule, which is our next step. And finally, from the statements that we gather from our pattern rule, we will be able to finally accomplish the final, which is what? The algebraic expression. And since we need to go from words to mathematical expressions, we need to be comfortable with terminologies that relate the terms that we write down on the pattern rule to finally the algebraic expressions. In this part, we're going to be looking at table of values, and table of values involves the following. First, we need to recognize that there are components that makes a table of value. The first component is known as what? A T table, and this is how it looks like when you are designing your table of values. And this is how a T table looks like. It is just a T, where on the left side, which is representing your column, your left column is known to be covering what? The term number, and the term number is highlighted on the left side, and this is used to explain what? The numbers that are represented on your graph, which are laying on the x-axis, and so relating the right column to another variable, and this other variable is known as the term value. And the term value is represented as how many items that are in a term number. And this, when you look at it, it is covering what? Numbers that are on the y-axis. And so once you're able to recognize these two, your term number, which is the position, or in this case, looking at your scenario, we are going to transform this general term to a more specific term. To this particular scenario, we recognize that our term number is expressing our figure number, in this case figure 1, figure 2, or we can say position 2, or second position, figure 3. And so we can apply the figures number to our term number. And so our term number is represented also as figure number, while our term value is going to be the number of items in that figure. And so the items we'll be looking at is the number of sides, or we can say the number of sticks that makes that figure. By filling out the table, we realize that yes, well, for figure 1, we know that the number of sticks are 1, 2, 3, 4. We write down R4 for figure 2, and we're going to write 7 for figure 3, which has 10 sticks. We can not only determine what the changes are in terms of the next step, but also we can determine the future number of sticks in it. So what figure contains that number of sticks? However, when we look at this and we change our term value representation from number of sticks to, let's say, what we see directly, which is squares, and so if I change this here to number of squares, what is going to be the result? Where is going to be the outcome? And the outcome here is as follows. when you're doing the counting of squares, we observe that there is a direct relationship between the figure number and that of the number of squares, and this implies the following. We see that figure 1 has 1 square, and that means that we're going to put our 1, and for figure 2 we have 2 squares, which we have right here, and finally for figure 3 we have 3 squares. You should be able to take advantage of this method here, which involves the number of sticks. So for some teachers, if you deliver these as your table of values, the figure number to the number of squares, knowing fully well that there is another characteristic object that differentiates this here number of squares from itself, then it means that this is rendered to be a lower level in your grading system. And so you need to be able to recognize this, that hey, not only do we have number of squares to be the same as a figure number, but you can also categorize your number of squares as the figure number here, and then you can show the relationship between the number of squares and number of sticks required to create a number of squares. And so that is something to keep in mind when it comes to designing a table of value that is more representative of the entire scenario right over here. Next step is moving from table of values all the way now to something known as the pattern rule. And the pattern rule explains what is happening when you're relating one property to another property. In this case here, what we are looking at is not the relationship from figure 1 to figure 2 to figure 3, like as shown here, where you're going, hey, from the first figure to the second figure, we're adding 3 sticks, which is just the pattern rule that you're familiar with. And from this particular scenario to the next scenario, we're adding 3 sticks. Rather, we're looking at a pattern going from the term number, which is what we have right here, to the term value, which is what we have right over here. And so this here is a pattern rule that we are going to be looking at, and how to determine it is based on how your x relates to your y, how the figure number, or from our previous analysis, the number of squares to the number of sticks. And developing our pattern rule states that, hey, looking at our figure number, we are going to see that 1 going to 4, 2 going to 7, 3 going to 10 share the same relationship. But to determine the relationship, first we need to look at the term value, number of 6, and see what relationship is common going from 4 to 7, and it must be the same as going from 7 to 10. And in this case, we see that we have plus 3 going from 4 to 7, likewise going from 7 to 10, which is plus 3, which means that our 3 is going to be what? Our 3 is going to be multiplied by our 1, multiplied by our figure number 2, and multiplied by our figure number 3. And this will take us to what? 3 for the figure number 1, and next is for figure number 2, takes us to 6, and for our figure number 3 takes us to 9. And so once you're able to recognize this, our final part is going from 3 to 4 must be the same change as going from 6 to 7 and from 9 to 10. Remember that we are journeying from term number to term value, and therefore what we realize is that, hey, once we add 1 to 3 we have 4, likewise from 6 to 7 we add 1, and finally from 9 to 10 we add 1. And so therefore, what is the pattern rule going from our term number to our term value, the pattern rule is that yes, we are going from what? A term number. We first multiply by 3, then add 1 to get the term value. Now remember here that our term value represents what? The number of sticks, while our term number represents what? The number of squares, or you can say what? The figure number. And once you're able to address these as our pattern rule for this scenario, we are now going to move on to the final step, is moving from pattern rule all the way to what is known as the algebraic expression. And algebraic expression implies what is the expression that relates what? Our term number, which is shown right here as number of squares or figure number, to the term value, which is the number of sticks. And now for way to accomplish that, we are going to be using variables that we already established on our table of values to represent our term number and our term value. So in here, what we realize is that yes, for our term number, the variable that we are going to be using is x, and therefore what that means is that x is what? Multiplied by 3, which means our x is multiplied by 3, and then add 1 after we perform the product of x and 3. We are going to get, which is equal to what? Our term value, equal to our term value, which is the number of sticks expressed as y. This is also written as what? This is also written as 3x plus 1 equals y. And the significance of this goes beyond just algebraic expression. You can determine any future term value given a term number by just putting in the specific term number or figure number or number of squares for x, and then by solving you can be able to determine what the number of sticks are, which represents our y. Likewise, if you're given the number of sticks and you're asked to find how many squares is required given that number of sticks, all you do is you put in that given value for the number of sticks in this expression or equation, and then you can solve for x. And so other things like, for example, building a graph will also be important, not only from using table of values but also using the equation, where this +1 tells you where your line touches what? The y-axis, and our 3 is how your line is increasing within your y change to the x change. And so that is how it looks like when you're looking at the benefits of this algebraic expression. So a challenge question might be this: how about you do the same things that we did right from the beginning, table of values, all the way to algebraic expression, but apply this strategy to this question. And the question says, given the pattern, triangle, and then you have this triangle, and then this triangle right here, and what is going to be what? The figure 10. How many sticks will you use to create figure 10 or 10 triangles? So hope to see you all on the next one. Stay smart as always and believe in yourselves.